Hi there, it's Mrs. Ortiz, and we are doing Geometry Honors Objective 1.4, um, which is called More Equations with Segments and Angles. So we are continuing to talk about segments and angles, which are the two things in geometry that we can measure, and how we can write equations. And basically, our equations are going to be based off of knowing the definitions of the terminology we're going to talk about. So lots of definitions today, and then understanding how those definitions can translate into equations. So using like geometrically and algebraically. So today's essential question, how do we use geometric terminology to write equations for segments and angles? So we need to know what the definitions are. So we're going to say, by knowing definitions, so knowing definitions of geometric terms, allows us to write equations. And that's today's essential question. Okay, so how do we use geometric terminology to write equations for segments and angles? By knowing definitions of geometric terms that allows us to write equations. So let's jump into it. Nothing more exciting than learning definitions. So the first definition we're going to talk about is a midpoint. And just like it sounds, mid meaning middle and point meaning point, a midpoint is the point in the middle of a line segment. Okay, so a midpoint is the point that divides a segment into two congruent segments. Okay, so a point that divides a segment into two congruent segments. So let's see what that looks like, and then let's talk about how you can use that to write an equation. So a midpoint, if you were to see a midpoint on a picture, you're going to see a segment. So maybe we have a segment XY. Okay, and if it's a midpoint, then it's got to be smack dab in the middle. Now, to know that it's a midpoint, we have to show that it divided it into two congruent segments. So we have to be able to say that XM is congruent to MY. So what this might look like if you are reading about it, like in a problem, you might see something that says M is a midpoint of XY. Okay, and from that from that statement, you are going to be able to make the conclusion that XM is then congruent to MY. Now, a statement of congruence is not an equation, okay? But things that are congruent are, as long as their segments or segments or angles, segments or angles and angles that are congruent are also equal. So then we can conclude that XM is equal to MY. And now you have an equation. Okay, so you've got the figure, what it might look like in a problem or how to write about it, the conclusion that you can make, and then from knowing that they're congruent, you can conclude that they're also equal. Okay, the next definition is going to be a segment bisector. So this is a very similar idea, except that segments can be cut in half not just by points, but also by lines or rays or segments. Okay, so a segment bisector is a line, a segment, or a ray that intersects a segment at its midpoint. So what this looks like, okay, so a line, segment, or array that intersects a segment at its midpoint. It looks very similar to midpoint, except that it's not going to be necessarily a point that intersects a segment. So if we have a segment AB, and we have a line XY, okay, it can, XY is the bisector if it divides AB equally, so that AY is congruent to YB. So in this case, we can say line XY, and remember that that can be a line, array, or a segment, bisects segment AB. That might be how you see it written in a problem, or if you want to write about it, that's how you would write about it. What this implies then is that by definition, AY is congruent to YB. Okay. Now you could have XY and you could have your Y down here as being a point somewhere else, right? Or maybe I could call that Z and say that line XZ bisects AB, but Y is my midpoint because that's the intersection of the segment. And then if AY is congruent to YB, we can also conclude that AY equals YB. And there's your equation. Okay. All right. So an angle bisector, just like you might expect, is something that cuts an angle into two congruent parts. It cuts an angle in half. And so the only thing, if you think about a picture of an angle, the only thing that can actually cut an angle in half is a ray. So an angle bisector is a ray that divides an angle into two congruent angles. Okay. So what does an angle bisector look like? So any given angle, so we'll name this angle M, N, P, and if it's being bisected, then it's got a ray that goes right down the middle. And then to indicate that it's actually going down the middle, it has to show that it's cutting it into two congruent parts. So we're going to mark our angles congruent with congruency notation with our arcs. Notice that I staggered my arcs so that I can see that I'm referring to those two angles rather than one arc that would refer to the big angle. Okay, so I'm going to erase so that I have space for this. Okay, so if we are talking about an angle bisector, then we might say we're going to see something like ray NR bisects angle MNP. And then that's going to allow us to make the conclusion that angle MNR is congruent to angle RNP. Now there's two ways you can see these problems, right? If you're given an exercise or a problem to do, you might be given a figure that shows that it's a bisector, or it might be written in words. And so that's why I'm trying to give you the different ways that you might see this. Okay, and then if those two angles are congruent, we can also make the conclusion that they are equal, and that allows us to have an equation. So if angle MNR is congruent to angle RNP, then the measure of angle MNR is equal to the measure of angle RNP. All right, so those are all definitions for the middle of segments and angles. So if you are looking to know that something like a point or array is right in the middle of a segment or angle, you are looking for the language midpoint, segment bisector, or often just referred to as a bisector, an angle bisector. And again, that could be just referred to as a bisector, and it's just based off of the context, okay? So The next vocabulary we're going to talk about are the types of angles, so classifying angles. And there are 4 angle classifications. So the first is an acute angle, and that's an angle that measures less than 90 degrees. Okay, and so it might look something like that. All right. An obtuse angle is an angle that measures more than 90 degrees but less than 180. So an angle that measures between 90 degrees and 180 degrees. That might look like that. A right angle is an angle that measures exactly 90 degrees. And so a right angle looks like this. And actually, when we look at figures to indicate that something is a right angle, you get the little box in the corner, and that will tell you that it is a right angle. Okay, and then a straight angle is an angle that measures 180 degrees. And so that looks like a straight line. Okay, and it can have a vertex. Well, it should have a vertex as an angle, but there's no indication. You just identify it by noticing that the 2 rays make a line. So you know it measures 180 degrees. All right, types of angles. Okay, angle pairs, so more definitions. Okay, so complementary angles are 2 angles with a sum of 90 degrees. So 2 angles with a sum of 90 degrees. All right, and complementary angles might look something like this. Okay, so we might have angle 1 and 2, and then a right angle indicator, and we could conclude from that image that those angles are complementary. So we could say angle 1 and angle 2 are complementary, or they are complements of each other. Okay, and then that allows us to make the conclusion that they add up to 90 degrees. So we can actually write the equation that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. So by knowing they're complementary angles, we can go ahead and make the conclusion that we can write an equation. Supplementary angles are 2 angles with a sum of 180 degrees. So they might look something like this. Say angle 3, and we'll do an angle 4. Okay, and we would say that angle 3 and angle 4 are supplementary angles or supplements of each other. And from there, we can conclude as an equation that the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Okay. Adjacent angles, this is important vocabulary, but it does not have an equation. So adjacent angles are angles that have a common vertex and side. Okay, so angles that have, adjacent means next to, so they're 2 angles that are next to each other. A common vertex and side. So there's a ray. Okay, so adjacent angles look like this. They share a vertex and a side. Okay, and we can say angle 5 and angle 6 are adjacent. So we use this as an adjective to describe angles and understand what a picture might look like or describe how they're placed next to each other, but there is no equation that comes from this, okay? So if we go back to our complementary angles, those are adjacent angles, and our supplementary angles are non-adjacent. They are not sharing a side. There's space between them, okay? All right, so more vocabulary that's going to give us more equations. So we're going to go ahead and go to the next page and talk about vertical angles and linear pairs. So vertical angles are two angles. Let's zoom in here a little bit. So two angles with a common vertex. So they share a vertex and sides that form opposite rays. Okay, so in a picture, it might look like this. So usually it's going to form some kind of X shape. And we are going to see two angles on opposite sides of the vertex. And we would say that angle 7 and angle 8 are vertical angles. And in a minute, we're going to get the definition from a theorem. So you learned about theorems in the previous lesson, but we'll get to that in a minute. And then a linear pair, you've already talked about this from the previous lesson, and I really should have put the definition there, so we've probably already talked about this, but just to review, a linear pair is two adjacent angles with a common vertex that form a line. Okay, so by definition, we can identify linear pairs. So we need to have adjacent angles like angles 9 and 10 that together form a line at their vertex. And we say angle 9 and angle 10 are a linear pair. And then you know from the previous notes section, the linear pair postulate says that we can say the measure of angle 9 plus the measure of angle 10 is equal to 180 degrees. Okay, let's go back and talk about vertical angles a little bit. So we define vertical angles so that we know what they are, okay? But you can actually follow the definition up with a theorem that allows us to talk about, it's going to allow us to write an equation, okay? So vertical angles is just the definition, but the vertical angles congruence theorem gives us a relationship between those angles. So the vertical angles congruence theorem says if two angles are vertical, okay, so if two angles are vertical angles, then they are congruent. Okay, so that's the theorem. And so what that might look like, again, we'll give another example of vertical angles. And we could say that angle 11 and 12 are vertical angles. And then we can say, so if we can conclude, if we're given a picture like that in the figure, we can say that angle 11 and angle 12 are vertical angles. So we can conclude from the theorem that they're congruent. So then we can say angle 11 is congruent to angle 12. And like we talked about with our other definitions, if the angles are congruent, then we can conclude later that the measure of angle 11 is equal to the measure of angle 12. Okay, all right, so I'm going to stop there and I will create a second video that goes through the examples for this vocabulary. Have a great day. Bye.